Hi, I'm here to explain the solution to rooted subtrees. So just to recap quickly, in this problem, you're given two trees, or you're given one tree, but you're given two rootings of it, and you want to count the number of ways to select a subtree in the first rooting and a subtree in the second rooting, such that it gives some intersection, and you want to count the number of distinct possible intersections you can get. So off the bat, let's just focus on the left rooting. There's n possible subtrees in this tree, right? And you can get all of them by just choosing the root of the right subtree. So we know the answer is always going to be at least n. Now the question is, given the left subtree, or given the left rooting, how many ways are there to get a subset that is not actually a subtree? And we can look at the nodes on the path between the two roots and subtract out certain parts. So for example, to get all of this except for node 3, we can select the root and we can select everything except for node 3. It turns out that for any subsegment of the path between the two roots, we're able to select that subsegment and any subtrees that are hanging off of that. So let's say there's k nodes in between the two roots, and then there's k choose 2 ways to select a subsegment there. And now our problem has reduced to finding the number of nodes between two nodes in a tree quickly. So there's a bunch of different ways to do this. You can use a sparse table. You can use a segment tree based on the depths of each node in the tree. Targin has an offline algorithm to compute this. Regardless, your runtime is going to be something like big O of n plus q log n, and this should be more than fast enough to run in the very generous time limit.